afternoon, everybody. I hope we are doing well today. I had to hide the title of the lesson so that the whole warm-up could fit. So if you didn't get that, the lesson was lesson 8.2. Make sure you titled the paper. But let's jump in and see how we're doing. Got some ideas from the previous lesson and some ideas from the distant past. Let's see how we did. Number one, I would like the values of x and y. The values of x and y. When I call your name, you give me both of them. All right, I got student number 21 and student number 6. Student number 21. Okay, student number 6. Okay, so we have a disagreement. Student number 2, what do you say?
X equals 2 and y equals 4.
X equals 2, y equals 4. Number 2, the measure of each angle. Measure of each angle. I got student 5, 13, and 10. Student number 5, what do you say?
The measure of angle F is 80, the measure of angle G is 160, the measure of angle H is 145, the measure of angle J is 130.
All right, let's stop there, because F and M are going to be the same, G and L are going to be the same, and H and K are going to be the same, so we can stop there. So let's see what student number 13 says.
The measurement of angle F equals 80, the measurement of angle G equals 160, the measurement of angle H is 145, and the measurement of angle J is 130.
Was that the same thing that you said?
Yep.
Student number 10, do you agree? You agree as well? So, those are the measurements. I did not include K, L, and M because they were the same as the other angles on the other side. So are there any questions from you before I talk about a couple of things? We'll start with Tristan and Brandon. Tristan. Number 2. Okay, Brandon, what was your question? I'm sorry? In number 1? Okay. So let's start with number 1. Can I have thumbs up if you got number 1 correct? Thumbs up if you got number 1 correct. Good. Kisara, what did you do to get Y? Very good. So you set them equal to each other. So you set them equal to each other because what were they called again? Alternate interior angles. It was a little hard to see because this was kind of drawn in to indicate that that was the spot. But yeah, absolutely. Very good. Okay. Brandon, does that make sense to you? Was it because you couldn't see that this was indicated to be in that spot right there? Oh. Okay. That's reasonable. Oops. All right. And Tristan, your question number 2 was just how? Okay. So give me a thumbs up if you got number 2 correct. Good. Alyssa, how'd you start? Okay, well, you're onto something. So what did that get you? And the 900 represents what? Beautiful. Okay, so we used the theorem from yesterday, the expression n minus 2 times 180. That told you that the sum of all of this must be 900 degrees, right? Good, Daniela, you also said you got this question right. Was that the first thing you did? Yeah? Okay, from there, what did you do? Okay. Okay, very good. Beautiful approach. Beautiful approach. So Tristan, I saw kind of a little spark go off when she started talking about getting the sum. Was that the missing piece for you? Just getting the sum right off the bat? Okay, good. Any thoughts, any observations, anything at all on today's warm-up? Yeah. So any idea why I did that? Okay. Any idea why this was in today's lesson? Any thoughts on that, Brandon?
The line. Wait, no. Never mind.
Okay. Well, I do have a question. This relationship right here, which is really this angle over here, what is that relationship called? That was a less frequent relationship that we used. Sebastian? Consecutive interior angles, yeah. Very good. All right, well, we'll see why Mr. Gallup put that in today. We'll see. All right. Any other comments, questions, any theories, any observations? So, you can already see that we're moving into parallelograms. And like the time we spent on triangles, which was a huge amount of time, we're going to be spending quite a bit of time on parallelograms. You're going to find out why in a moment. So our major objectives are to understand, be able to apply properties of parallelograms. The properties that I'm referring to are actually on your cheat sheet written as theorems. We're going to talk about that in a moment. And also, of course, to be able to solve problems. And the only new vocabulary today really will be the actual use of the word parallelogram. Okay? So, first, just the basics. And you guys, we know that there's certain things you guys don't need to write down. So this is not up here so you'll sit and diligently copy. This is just to set the groundwork, set the foundation. So any shape that has four sides, quadrilateral, we already knew that. But some quadrilaterals have special names, and one in particular is a parallelogram. The definition of a parallelogram is that pairs of opposite sides are parallel. If that is true, it's a parallelogram. Okay? And we see one right here. Any questions right off the bat? So, now I'm going to use something that I have reproduced for you on your cheat sheet to try and give you an overview. Find on the second page, find this diagram, this flow chart. And I put this here so that we could try and kind of have a framework for what direction we're going. So up here on top, we have just all different shapes, all different quadrilaterals. But then you see we've got basically three different branches. And which branch is by far the biggest? Parallelogram branch. And so you can see when you look at it this way that the parallelogram leads to these other major, incredibly important ideas. So the parallelogram becomes the foundation for a whole bunch of other ideas. So we're going to be spending some time on it so that when we move to these other ideas that it makes perfect sense. Okay? Any questions about that? On the back of that same sheet, I have a different way of looking at it. It's the exact same thing, a different way. But you can see that the area of this diagram that takes up the most space and has the most ideas within it is the parallelogram area. And this shows you, in a different way, how each special quadrilateral relates to other ones. So for example, you can see that a rhombus, since it's inside the parallelogram area, a rhombus is a parallelogram. And you can see that a square, since it's inside the parallelogram area, a square is a parallelogram. But what else is a square? We've got a bunch of people right off the bat. Caleb? It's also a quadrilateral because it's within the quadrilateral area. What else is a square? Michaela?
A rhombus.
Also a rhombus because this overlap area, it's also within that, so it's also a rhombus. Chris? Okay. It is a polygon as well, absolutely. So this is all within the realm of polygon, and no one did say rectangle yet, so you were right about that as well. So this is, again, just to give us a framework of what we're working on. Any questions so far, Catalina?
I've never been, and I think I already said this in like the beginning, but I've never been able to tell the difference between how they say squares are rectangles or rectangles.
And this is it.
Yeah, but like why can't a rectangle be square?
Because it's about the details. A rectangle is not a square because a rectangle doesn't have 4 equal sides. So certain things can go one way and not the other. Okay? And you're going to learn more about that as we go along. Okay? Chris, another thought?
Actually, a rectangle could be a square, but that defines a square.
Say the last part again.
It could be the third part, it could be a square.
That's right.
A rectangle, and also be a square and a rhombus.
That's right. Okay? Well, we'll explore more as we go along. We'll see if he's right. Any other thoughts? All right. So now, the theorems. So now something different. I've talked to you about names of theorems, and I've talked to you throughout the whole year about the fact that, it's hard for me to tell, since this is my first year, which ones you have to remember the names of and which ones you don't. And I think we've learned as we've gone along that some just kind of naturally sunk in. Did someone just name a theorem that they just kind of know? One that we've used a whole bunch of times. Or whatever, it doesn't matter. Base angles theorem, right? Tends to be more memorable. Triangle sum theorem we used a lot, and a bunch of people just kind of threw their hands down because that's what they were going to say. Pythagorean theorem? Yeah. Pythagorean theorem, absolutely. Pythagorean theorem. So, certain ones have stuck with us, and some, we don't remember the names, but we remember the ideas. Well, now the names are immaterial. And I did some research, and I tried to find good names. They don't, from what I've seen, they're not out there. So here's what's important, the idea. And so the good news is that the pressure is off. There's no name to remember, it's just the idea. Okay? So we're going to go through each of these ideas. We're going to explore them. We're going to use them in different contexts, in different problem-solving scenarios. Yeah?
But will we have to use, like, do you have to remember those numbers, like, when you have to prove something?
Okay, so very good question. 1 second, Brandon. So when we get down to a proof, and we're going to actually see this today, is you don't write the theorem, you write the actual concept using shorthand. So you would say, like, if quad is parallelogram, then you would put op is congruent. I mean, you could just shorten everything so that it's like a couple of words and a few symbols, and you can get your message across. And you're going to start seeing that today. So very good question. Brandon?
I forgot to say this earlier, but is there going to be a name for special types of concave quadrilaterals?
I think you asked something about that yesterday as well. I don't have an answer for you yet, so I'm going to have to do some research, okay? So don't forget your question, and don't forget to bring it up again, because I haven't done the research yet. Okay, so there's 4 major ideas, and so I don't want you to think of them as theorems. Theorems. Think of them as properties. These are just ideas that all revolve around the parallelogram. For example, if a quadrilateral is a parallelogram, the pairs of opposite sides are going to be congruent. Pairs of opposite sides are congruent. Pairs of opposite angles are congruent. Honestly, I think logically and the way you guys think and the way you guys work, I think that either you already knew or makes logical sense as you think about it now. Here's why I did today's warm-up. if you have two angles on the same side, that's consecutive interior angles because it's a parallelogram. Think about the word. These sides are parallel, and if I took away that side, we just have parallel lines. That's consecutive interior angles. And so consecutive interior angles are always what? Supplementary. So they will always add up to 180. Dalton?
Because you can always make a transversal right?
That's right. Well, this is the transversal right here. That's the transversal, that's the parallel lines. Yeah, absolutely.
That's how I found X batted about the theorem before.
That's fine. Good. So you knew the idea, but you didn't know the theorem. So that's fine. Okay, so here's the one that might be a little bit new, is that if we draw the diagonals for a parallelogram, they will bisect each other. And so what is happening here is that this diagonal going from one corner to the opposite is now bisecting this diagonal. And so what we end up with is a segment congruent to another segment, and that segment is congruent to that one. They're bisecting each other. And so we can use that to solve problems. Any questions about the basic ideas? So now let's start using them, all right? So we're going to start with basics, and then we're going to quickly change to more complex scenarios. Just want to kind of get, it's kind of like getting your feet wet, just kind of get the ideas out there, and then we'll get more complex.
Creating them? I teach geometry over at Deerfield, so it's nice to have somebody to talk to, because you're the only geometry teacher here too, right?
Mm-hmm.
Yeah.
For those of you
We're in our
who,
own world.
if you've heard me say that I need to consult with somebody about it, you heard me say that over the year,
Yeah.
she's who I'm calling or emailing.
Not like.
So thank you. Yeah. Well, I'll talk to you in a minute. All right, so find the values, and give me a thumbs up if you feel like you can already find the values. Keep your thumb up if you actually already found the values. Yeah, see, I'm too slow for you guys. So Davis, what did you get for x?
X is 8.
Okay, you sure? Because I asked you to keep your thumb up if you already got the values, and then you hesitated. Maybe I put some pressure on you? Okay. All right, so you think it's 8. Alyssa, you agree? What about y? Alyssa, you got y? Okay, so we can already see the properties of the parallelogram in effect. This is a parallelogram because this is parallel to that, that's parallel to that. So I want to make something clear that I've talked about before. Make sure you establish the facts before you then use that to help yourself. For example, if you just assumed it was a parallelogram and didn't actually look for evidence for it, you made a small mistake. You have to make sure that the evidence is there that it's a parallelogram. And it is. The evidence is there. And so then we know that opposite sides are congruent. So for this to be true, x would have to be 8. Of course. And then Alyssa, you figured out that y had to be 65 because of what? Yeah, they're congruent. Opposite angles in a parallelogram are congruent. So not very complex, right? But again, just trying to get the ideas out there. Any questions? All right, so and I apologize, my G got cut off. This is the G over here, top right corner. So right off, just looking at it, seeing the picture, what immediately came to mind that we can use or kind of explore to solve this? J?
Segments EG, J, and JG
Are they? Okay, why are they?
because the shape, the outer shape is parallel.
It is? Is there evidence that it's a parallelogram?
It's told to.
Oh yeah, it says it right there. Okay, good. So it's a parallelogram. And you say that you claim that this is congruent to that. Okay, and I asked you why, and you said because it's a parallelogram, but now we need one more piece of evidence. Why are they congruent? She's right, they are. Go ahead. Yeah, this is EJ, and I love how you said that. EJ is congruent to JG because FH is bisecting it right there. That's why, okay? But you're absolutely right. Very good. So we're asked to find JG, but to do that we need W. So what can we do? Got 1, 2, 3, 4. We got a whole bunch of people. Tristan? Very good. For this group, you probably just do it mentally. Maybe even didn't need to write it out. You probably just mentally figured it out. So what does W equal? Dalton? W equals 4, and so JG equals? JG equals 12. Very good. So JG equals 12. Very good. Any questions? Any concerns? And go.
We would prove quadrilateral congruence if we had to do it, or would we have to do it because some of the ideals you can't just like prove it congruent,
All right,
just because.
hold on. Alright, so Anne, I'm trying to understand your question. So the beginning of your question was if we had to do what?
Like if we had to do a proof with a quadrilateral, would we prove them congruent or similar?
Let's hold on to your question, go through what I've set in the path I've set for us today, and see if your question gets answered. Okay? So don't forget your question. If you need to jot it down quickly, go ahead.
Are we gonna use like these properties and compare and like those the fact that they bisect each other, the diagonals bisect each other? Are we ever gonna use it to find the point of J?
Again, hold on to your questions. See the path that we're going through today. See if I answer your question. Okay? Good. So here we go. Checkpoint number 1. 2 parts. You got 2 minutes. If there's time left, then by all means discuss your answers with your team and see if you came up with the same results.
You're provoking my movements. You're purposely trying to cause a strife to both of them. What's it? Maybe it'll be fine. Where's my next song? That's what you gave me. Go get upstairs. Who are you talking to like that? 180 minus 30 is 180 plus.
Wait, no, wait.
Yes.
So,
A Z? Okay, next one.
I called him.
Wait, what'd you get right? I have
Okay, thank you. Okay, so let's see how we did. Equity bars in effect. Stay on your toes. So we got part A. Part A. We got student 19, 24, and 1. Student number 19, what do you say? Okay, student 24. So you guys agree student number 1?
YZ equals 52.
So you all agree that it's 52? YZ is 52. Part B, what's the measure of angle Z? I got student 13, 8, and 15. Student number 13.
the measurement of angle Z is 65 degrees.
Okay, student number 8.
The measure of angle Z is 65 degrees.
Student 15. 65 degrees. Any questions, concerns, any observations? Tristan. Okay, how'd you find the measure of angle Z? We got a whole bunch of people who had some ideas. 1, 2, 3, 4. And what you got? Bless you. Yeah. Okay, so go ahead. Tell me what your equation was. And I love the beginning of your explanation is because these two angles are supplementary because they're consecutive interior. So they had to add up to 180, solve the equation. Okay? Does that make sense? Okay. And I know there was 3 other students. Did anyone use a different method? And you all use the same method? Okay, good. Any other thoughts? Any other questions? Good, so let's go next level. And this time, even though it's not a checkpoint, I am going to give you some time to set this up. So we've got 3 points that are vertices of parallelogram JKLM, and you are allowed to denote a parallelogram by drawing a little parallelogram. But what I'm asking you to do is find the coordinates of vertex M. I've only given you 3 out of the 4. Beyond that, we need to supply evidence that it is actually a parallelogram. I know I'm telling you it is, but then I would like actual evidence to support that it is. So first I'm going to give you a couple minutes to get this set up, and then we're going to come back as a whole group to see what we've figured out. So take 2 minutes to get yourself set up. If you don't have a ruler at your desk, I mean you should, but if you don't, come up and get one. If your ruler is not in good condition, come get a different one.
We do scale by 2, or do you want to do it?
Whatever you feel comfortable with. I think it'll be a better experience if you go by ones, but I'm honestly not sure.
Any website, exactly what happened, and then add to home screen, yeah. Some of this stuff, see, this was like stuff good, so stuff, and gizmos, I paid my login ID, listen, at least it allows you to access and use it. The kids won't be able to create accounts, because they don't have I won't have enough, so at least you'll use it, like, the display, and have kids come up and
Well, I appreciate it.
because it doesn't matter, nobody's like keeping track of it.
My,
You're not gonna say, why is that money, use it as far as stuff.
Well, I appreciate that. What I've been doing is I've been doing Juno. So if I want to demonstrate something, I'll send that to you. Last week I had to
Yeah. Yeah. That's what I've been doing too. I've really been trying to have them discover the properties and then
Well, I
try
know
to
you said
try to get them.
I have.
Kind of. Next year. Next year.
I'll be. I've done it.
Yeah.
Sometimes, like
What the, there's another file.
Oh, yes, I was talking about.
it's from a different publisher, it's a different series.
Yeah.
8, 8.
There's some investigations too.
Let's see, that one over, that one over.
No, I lied.
The text.
And so we do some,
Unless I better go because I'm already ready now. But it was good to see you. Let me know if you need anything. I'll email you some important stuff that was there and, yeah, I know, I wish I could play it. Awful, I've been waiting for the plan.
I know, it is tough. Well, if you feel like you need to come back out, take a break, come on. Thank you so much.
Thanks, good luck, kids.
All right, so hopefully you set up. That's what I want to do. And so we've got the 3 vertices are at 3, -8, so I'm going to have to go way down. 1, 2, 3, 4, 5, 6, 7, 8. And we've got -2, 2. And I apologize, 2, 6. And so we label them. We've got J, K, L, J, K, and that is L up there. So the question is, where would point M have to be to make this a parallelogram? Where would point M have to be to make this a parallelogram? Anyone have any ideas already? Okay, we got Ania and Brandon, Chris. Ania.
Wait, I'm sorry.
Okay, and where do you think it should be? Okay, Brandon. Okay, Chris. Okay, thank you. So 7, -4 is a proposal. Okay. Go ahead.
-1, -12.
-1, -12.
Yes.
So that's going to be way over here. You guys said I'm sorry, you said 7, -4 over here. 1, 2, 3, 4, 5. Over here. Okay. So I'm going to give you another minute to explore and maybe compare with your team and see if you can figure out if one or more than one point would represent a correct answer. And then the second question, how would you prove it? How would you prove that it's a parallelogram? So go ahead and take another minute to go ahead and try to figure that out. Try to iron down what you think the actual point will be. Make sure you know the coordinates of it. Try to have an idea of how you would prove it.
This distance has to be the same as so it's like
Yeah, but like,
Most distances has to be the same.
isn't that like,
yeah, you want to walk forward, I was down.
isn't that like,
Yeah, like
Like,
you can
oh,
do that.
like, one of your words for sitting down.
I will when it's time.
It would be like.
I heard that. No, they don't. No, they don't. No, because you can draw K-N instead of L-N.
It's JKL.
That's how we know.
Okay, so
You just didn't read the top part.
okay, so what do we think? What do we think now? Now that you've had a little more time to really pin down what you think. Brandon, back to you. What do you think? 7, negative 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Your proposal is that point right there. Okay?
I think it could be both.
Both. I don't see
7,
one.
negative 4, and negative 1 and negative 4.
Someone else had proposed negative 1, negative 12. I believe that was you, Brian.
Yes.
So negative 1, negative 12, negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to have to estimate. I'm going to have to estimate. I'm going to have to estimate that it's about there. So you think it could be both of them, okay? Zavari, you have a thought, and then Michaela.
How can it be that point? Because wouldn't it have to be in order JKLM, not J?
In order JKLM, you mean because it says JKLM, so it has to be in that order? Oh, okay, I understand that. Okay, Michaela, and then we'll go to Catalina.
I had with Tabari, I was saying with Tabari.
So since we're trying to add in M, you're saying that this has to be it because of the order of the letters. But then let me ask this question. If the letters didn't matter, would this form a parallelogram?
Yes.
Oh, you think it would? So Daniela, because you're the first person, you're the first person who said you thought both were right. Okay, so I heard a lot of people in agreement that both points will create a parallelogram, but only one of them is truly the correct answer because of this order of letters that came up at the beginning. I'll be quite honest with you, I never even considered the order of the letters. The other group that I worked with didn't consider that either, so you guys are the first ones to bring it up, and I see now that that probably would make sense. So that M would need to be here. But if we're sticking with the spirit of the question is a little more open-ended in that, so what I'm saying is, maybe that it's okay for that to be M, just for following the spirit of the question. Okay? So, Catalina, you were next, go ahead.
It's just a question. I know that we learned that that's the order and you have to say in that order, but can't you draw the diagonals and then just say the letters in any way?
I'm not sure. I don't think so. And unfortunately, Ms. Escobar left, so I can't consult with her. But from what we've learned over the course of this year, the order of the letters matters. And so if this is what's given to us, then the vertices would have to go in that order. So you cannot say J, L, K, M. That wouldn't make sense. Okay? All right. Yeah.
I was going to say, I think in previous lessons you said that we can't do that.
Right. Right. Ania.
Why don't you order
Because it tells you what path to take to create the shape. So in other words, if you say JLKM and you intend it to be JLKM, how would someone know what order to put it in unless they followed the letters? Okay? All right, so now the last piece, the most important. What evidence is there that this is a parallelogram? So let's stick with this location right now. What evidence is there that it's a parallelogram? Got 5 people with evidence, 8 people. We'll start with Jada, Davis, Danielle. Slope. Okay?
The length and the slope of the side of segments KJ and LM would be parallel to each other, and the segments KL and JM would also be parallel to each other.
So you say that these are parallel to each other,
Yes.
not just because I said it at the beginning, but because of what reason?
Because their slope and their length match up.
Okay, so what is the slope of these two? So let's go back to Jada, and then I'm going to go to Daniela. Jada, you said slope, and then you didn't say anything after that. Were you saying that their slopes were the same?
Yeah.
So what is the slope of KJ and LM? 1, negative 2? What do you mean?
1 over negative 2. I mean, it's negative, wait, I'm so confused now. Okay, rise negative 2, Run 1.
So the slope is -2, the slope is -2. So from what we learned last year, same slope, parallel lines. So we've got half of our proof. And now, if we go a step further, and as Davis said, now add in these, you're saying that we can prove it again, okay? Daniela, what was your thought on this? You were going to say the slope. Did you already figure out the slopes? Okay, so what's the slope of KL? I'm sorry? 4/4, which is slope of 1. And the slope of this is also 1? Okay, so there is our evidence. That is the evidence that proves it's a parallelogram. Okay? Any questions about that?
So, which M is right?
Well, based on the question, this location of M is the best answer. But as I said, the spirit of the question was really to find a point that made it a parallelogram, and this will also make it a parallelogram, but it'll be a different parallelogram. Okay? Good. Nicely done. Any questions? All right. Checkpoint number 2. And I'm going to clarify the instructions in a moment, but just take a second to read it to yourself. So, list as many facts. What do I mean? I want to clarify since it's not my normal type of question. I want you to list for me as many pieces of evidence, as many facts as you can about this diagram. I'll start. I'll give you the first one. Segment BC is parallel to segment AD. There is a fact about the diagram. Now you find me as many as you can find. After you find as many as you can find, after the bell rings, you're going to immediately count how many you found. Any questions?
Okay.
You got 3 minutes. Go.
Hey, Mr. Dallas, you need to say something like, if you said something bisects something, you need to switch it around.
I guess you could. You can, but for right now, I just want you to tell me things that you know for certain from the picture as it is. Okay? Good question. Bless you. writing your list, please stop and count. How many facts did you find?
I know what you do.
All right. So, how many did you find? How many did you find? Tristan? Sebastian? Davis?
11.
Maria? Zavari? I'm sorry? 13? Catalina? 11? Fung? 11? Kayla? 13? Brandon? Chris? 15? Jada? 12? 11? Good. So,
Yeah.
give me a fact. Give me something that you can state because there's evidence to support it. Okay, we'll start with Anne and work our way forward and then work our way back. Anne. I'm sorry? It's a polygon. Good. Alyssa. Shh. Say it one more time, please. You're certain? Good. You should be. Davis.
Angle BEA is congruent to angle CED.
Sure?
Yeah.
Good. You should be. That's a good one. Sebastian.
Angle BAD is equal to angle BCD.
Sure. Good. Brian.
Polygon ABCD is a quadrilateral.
Is quadrilateral. Very good. Michaela.
Triangle BEA is congruent to triangle CED.
You sure?
Yeah.
Really? I hope you guys are listening to each other to hear what other people are saying. So Maria, Jada, Chris.
Oh yeah, angle B, measure angle B plus measure angle A equals 180 degrees.
Okay. Jada.
Angle BEA is congruent to CED and BEC is congruent to AED.
Okay. So someone else said half of that, but good. Chris, and then Ania, and then Zabari. There are four pairs of congruent triangles. Okay. Ania.
Point E bisects point AC.
Very good. Zabari.
Polygon DABC is a parallelogram.
Okay. Very good. And there was, who was waiting? Someone up here was waiting?
Brandon.
Okay, Mikhail?
I don't know if somebody said it, but I think, I don't know if they did, AC is equal to BD. Congruence.
They are?
Is it?
If it's parallel. Segment.
There is no theorem that says that this diagonal is congruent to this one. The theorem says that this diagonal bisects this one, and what happens is because it's a bisector, this segment is congruent to this one, that segment is congruent to that one, but the whole diagonal is, in this case, not going to be congruent. Catalina, Fung, and then Brandon, and then we're going to wrap up.
I'm not sure if someone said it, but angle CED and BEA. Wait, no, it was our vertical angles.
Okay, it was actually said 2 times, but thank you for the 3rd time.
Sorry, I was checking.
Fung, I know, I appreciate it. Fung?
I was supposed to say segment AE plus EC equals AC.
Ooh, very good, very good. Brandon?
Not sure. Try and go back. It is triangle BAC and triangle CAB.
Okay, so checkpoint number 3, we go to team challenge, and we're doing it a little bit differently. So you're going to have to rely on your teammates to help you along because it's a little too much to do for one person. You are going to write 2 different 2-column proofs. You're going to write 2 different ones, which means you need 2 different paths of logic. And so the previous checkpoint was actually the same checkpoint, but I did it in 2 steps. And so your job is to prove that AEB is congruent to CED. But I want you to prove it 2 different ways. I want 2 different proofs. Okay? Use your team to help organize your information. You should have now an entire list of evidence to pick from. So, since I'm asking for 2 proofs, we've got a little less than 10 minutes. We'll see how we do with that.
I don't know. It sounds like Brian here. Brian, can you breathe?
All right. My intention was to stop here, but first I'll say that I'll pause here and let's check. And give me a thumbs up if you and your team have developed 2 different proofs. Okay, good. That's a lot of us. Good. So we are going to stop here. Put your thumbs down. So now I would like you to look at both. I'm sorry, we're back as a whole group. I'd like you to look at both of your proofs and look at the last reason for both of them. The last reason for both of them. Okay, so you're going to give me 2 reasons. So, what were your reasons? Kasara, what was your reasons? Okay. Was one of them easier to do than the other? You don't think so? Okay. Kayla, what was your 2 reasons? Same. Did you find either of them easier? Did one of them make more sense or anything? About the same. Okay. Daniela, what did you do? Same. Michaela, and then Shelby?
Same, but I mean, once you do the first one, it's easier to do the second one.
Ah, interesting observation. So you did the first one, and then some of the evidence from the first one was utilized in the second one. Shelby? Okay, very good. I like that. Go ahead, Kelly.
I feel like now that I've looked at one of them, I'm not sure if it makes sense or not. Because with the science one, so can I say?
Yeah.
Like what's what you call it? The gun shot or something?
Oh, the smoking gun?
See, now you made her laugh. Now you made her laugh. You're not gonna stop.
Okay.
She won't stop.
We'll come back for the gunshot in a minute. Okay. So, go ahead. You can gather yourself, and we'll come back to you. So then let me ask this. Did the list of facts that I had you do beforehand help you in developing the proof?
I forgot I had that.
No.
Kind of? Okay, Brandon?
Isn't the gunshot thing that's first?
Well, what you guys are talking about is a long time ago, quite a while ago, I was trying to help you guys develop the overall idea of a proof, and that I referred to that second to last step, sometimes as the smoking gun, that final bit of proof that seals the deal, so to speak, that clear piece of evidence that makes everything kind of work. Okay? Go ahead.
Well, the smoking gun from my side was Pythagorean theorem, but now that I look at it, I'm not sure if it could work because there aren't any values.
Yeah, so I'm not sure. I would have to look at it. There may be a way to do it. by having it set up for one. Well, no, you can't because there's no right triangles.
Yeah, right.
Oh.
Yeah, you got, and don't worry, you're not the first person to try and use. Remember, this happened when we were dealing with trig functions not too long ago, where people were using trig functions when it wasn't a right triangle, because we were so focused on using the functions that we forgot to make sure we were allowed to use the functions. Remember that we're developing a toolbox of tools, and certain tools can be used in certain situations. Okay? So, let me reveal my proof that I did. I only did one, but I knew there was a bunch of different ways to do it. So I started out by using the fact that it was a parallelogram. And I used angle, angle, side. So I first established that AB was congruent to DC because opposite sides of a parallelogram are congruent. And so here's an example from earlier. Someone had asked, I think Feng, you had asked, how do we write it in a proof? So notice I didn't put theorem 8 point whatever. I just wrote in shorthand, in a parallelogram, opposite sides congruent. And I could have even abbreviated opposite. Then I did alternate interior angles up here, and then vertical angles here, and we got angle, angle, side. Okay? So that was mine, and you guys already told me a bunch of different ways. Chris, you've been waiting. Go ahead. I'm sorry?
Oh, no.
Sine, cosine, and tangent. Okay? Any observations or thoughts on this final activity? So you guys did really well. I'm very proud and impressed with the work that you did. So, your homework is on page 512. You're going to do numbers 6 through 26. You're going to do 33, 36, and 41. 41 is an activity that you have to follow the instructions for, and I have to give you several sheets of patty paper to make it easy to do. So I'm going to do that in a moment. I'd like you to do the at-home tutor for 8.3, and you will have a quiz on 8.1 to 8.3. Today's Wednesday, so it's going to have to be next week sometime. I'm not sure when because I have to wait to find out the schedule for the writing test.